started. So for Lab 7, we talked about a ball purchase. So I put that ball purchase class in here, and I'm just going to remind you, there's one way that you can use ball purchase is that you can come along and you can say, because it's enumeration, you can give the name of the class in this case, dot, and then the name of the set of constants you're looking for. So if you do a purchase, you'll see that it's got, there's the get cost per ball, get deal name, the getters that I wrote already, and it's got a bunch of extras. And there's all of the constructors that you can use to make stuff. Okay. And so we can do your standard, get the number of balls from that thing. And since that was the 5 for 15 deal, the number that's going to be printed out there for the number of balls is 5. Okay, so nothing fancy there. The only thing that's weird about an enumeration is those sort of constructors that set things up at the start. The other thing that you can do, if you don't want to say ball purchase dot whatever on all of these, is you can say import static. Let's see if I can get this right. Ball purchase dot everything. And now, if you want to, you can just shorten that down and leave off the ball purchase name, if I did it right. Oh yeah, we're going to run into this little problem. This thing can't find the ball purchase. One of the tricks that you can play if you want to get it to recognize it, I think, is we can just drop it out of the default class. So let me do that. I'm going to make a new, where did it go? A new package, and I'm just going to drop it into not default. So this is an actual package name. And then if we just take all of this stuff and drop it in there, I guess I had one, didn't I? Drop it into bits and pieces too. Grab all these, oops. Grabbing is not very good today, and drop them into one of these guys. Come on. Fine, one at a time. Let me get them all dropped in here the slow way. Already in there. Just basically trying to get these out of the default package. Making my life worse, aren't I? That's okay. Official need. And there's my name. So there's something a little weird about, typically about enumerations, and they have to be in their own package usually, so that sort of works. So what I did was, a package is roughly the equivalent of a library name, so I just made an empty library name and then moved all the stuff out of the default to give it a name on the front, which is all that's done. So there's the name on the front, and it's still ball purchase whatever. And so now that ball purchase of 5 for 15 works. Okay, so it's just a little trick with packages. Okay, there's some controversy, by the way, in about whether or not you should write this way or whether you should not. You should leave ball purchase on the front to make it obvious where it comes from. The problem with this strategy is that if you have a lot of those names in there and you put a lot of these dot star things at the top, it's tough to figure out where the thing actually came from. Okay, so some people like to actually put ball purchase dot on the front all the time. Okay, but other than that, that's basically the trick to using an enumeration. You can now go and get any of those three values out of the enumeration. They're just fine. Okay, let's talk about one other little trick. Here's what we've been writing so far for lists. We've always been having to specify for our list, oh, okay, it's going to be a list of only fish, and put the word fish on the right-hand side all the time. This was true up until Java 1.6. Starting with Java 1.7, they made life a little easier. They made the compiler a little smarter, and so that works in Java 1.7. Okay, you can leave that angle bracket set there empty. They still have to be there to say of only, but now it's going to figure out that because the left-hand side said of only fish, the right-hand side has to be fish also. Okay, so if you want to save yourself some typing, that works. They're more or less equivalent. So you'll still see a lot of Java code that has the way we've been writing it, because that's the way you had to write it for a long time. Newer versions, starting with Java 1.7, you'll see people take the shortcut and write it that way. Okay, so there's just a little trick. Suppose I want to make a list of ints, of just simple numbers. New array list of only int. Notice it doesn't like that. And the error message is something totally weird. Thinks you're trying to make some sort of array because it's talking about dimensions for an array. The problem with ints is that they're not objects. And because they're not objects, you can't put them into a list because a list will only hold objects. Oops. Is there a way around that? Be sneaky. You need an object and you don't have one. Make an object that holds an integer. So what we'll do is we'll make a class called I'll just do it with a big long name for a start there, right? So it's an integer object, okay? And what I'll do for integer object is I'll put private int some number, or just might as well call it value, and then I'll write a constructor integer object, and all that it's going to do is it's going to take in and it's going to store that value equals in value, just like we've done for anything else. So basically hidden an int inside an object, and now I just need a public int get value to send that integer back out of the class. Okay, now that I've got one of those, what I can do in my sampler here is I can just use an integer object and now instead of doing int list dot add just a single number, what I can do instead is I can do int list dot add new integer object with whatever number we want inside. Okay, stuff an integer, a small little native integer inside an object. It's now an object, and since it's an object, I can now take that thing and use it in a list, and all I have to do to make one is just stuff that thing inside. So if I want to retrieve it again, I have to do int list dot get the thing at position 0, put that back into, shouldn't call it value, should call it, sorry, integer object. So the reverse of the process is to get the integer object back out of the list, so we'll retrieve it back out, and then if I want the actual native value, call the getter to retrieve it back again. Okay, so it's really, the thought process here is I couldn't use native integers in a list. What I can do is I can make a class that will hold a native integer. That class just has a constructor that takes a native integer, and it just has a getter that gives back the native integer, and we'll put those we'll put the object integers onto the list. We'll retrieve the object integers, and then we'll retrieve the small value, that's the native value, back out of the list. Okay, it's a lot of work. Okay. Now, it turns out that in Java, this happens enough that the Java guys came along and they made a class that does exactly what we just wrote. And instead of being called integer object, it's just called capital I integer. And again, we don't even need anything on that side, so you'll usually see it like this. And I think it's called, well, we'll just see. Int value. There we go. Okay? So that class already exists in Java. It's called, I usually refer to it here as big I integer. So it's just an object that contains an integer, just like we already wrote. Okay. This thing is known in terminology as a wrapper class, because all it does is it wraps up an integer, a small native integer, into a little box so that you can send the box around and then pull a little int out whenever you need it. Okay, so it's one of the smallest classes that you can have in Java. It has some other useful properties that we'll talk about later, but there's the first idea. Oh, now you can store them on a list. Okay. Well, it turns out that this thing gets really painful, because if I do something like if I add another integer to the list, so there's another integer on the list. Now suppose that I've got this list that's got two of those numbers on and I want to add them together. I now have to go drag out the individual pieces of each one, add them together, and then put them back. So for instance, if I wanted to sum up these two values into the 0 position, for instance, what I would have to do is I would have to drag out the other one. So let's just do that. I'm going to steal this code. I'm going to drag out, this is the second guy from the first position, and that's value 2. Go grab its value. I'd have to add sum is value plus value 2. Add them together, make a new integer, So drop the sum into that new big integer object and then replace it. So we can do int list dot set position 0 with the sum. Sorry, some integer. Isn't that awful? Right? Because the list can't contain native ints, so you have to make a big int to hold it, and then you end up with two big ints, so when you get them back out again, you have to go grab the getters to get them. You have to put them back, add them together in the native value, and then put them back into another big I integer so that you can store them again. It seems like a lot of work. It is so much work that they made the compiler writers do the work instead of us doing the work. And so in the modern version, in the latest versions of Java, what you can do instead look at that. The thing on this side is not a small native int, but it's actually a big I integer. When you do this, what the compiler does is exactly what we did up here. It makes a new integer, a new big I integer like we did, where did I do one? Like that. Okay? So that line is actually doing that. It's just that the compiler is smart enough to figure it out. Okay, so it translates this thing from a native type into a big I integer on that type. Okay, you can also do this. Almost. Oh. And what it's actually doing there is value something. First dot, whatever it was, int value. Okay, so all that's happened is the compiler is smart enough to write the correct code for you, or the more verbose code to do what you actually need to do. It's doing the work behind the scenes. Okay. In Java, that work of doing this little trick behind the scenes is called auto-boxing, because you take things and you automatically put them into a box and then pull them out of a box as necessary. Okay, so it's a little trick there. It usually works. It's not a bad idea. There's only two cautions about it. The first caution I have is it's surprising how seldom you need to use it, because most of the time you're not working with native types directly. You're working with a class that's got something inside of it, so it doesn't really happen all that often. And the second problem with it is when it does happen, it's easy in some cases to make a mistake where the behavior isn't actually what you expect. You know, it's a side effect. And so there are times when it actually does the wrong thing for you, and it's really difficult to pick it out, sort of like that go-to example that we saw. When it does something on your behalf and it does it wrong, it's really awful to try to figure out what's going on with it. Okay. But that thing will be handy a little bit later, those big I ints. Okay, let's move on and I guess we're out of time. So I guess we're stopping there for today. I've got some more stuff I'll show you for tomorrow's class that's related to Lab 7 that'll help you out a bit in places.